In this tutorial, I want to walk you through various examples of arbitrary beam cross-sections that you can build with MSc Nastrand's PBMSECT and PBRSECT entries. My name is Christian Aparicio, and I'll be going over today's tutorial with you. Now, this is what I want to do in today's tutorial. I want to take these traditional cross-sections here that you see here on the left, and I want to create these arbitrary beam cross-sections using various PBMSECT and PBRSECT entries available through MSc Nastrand. Here, if you look at this corner of the slide, you'll see that here we have these very exotic looking cross sections. This first one is a closed arbitrary beam cross section. Here in the middle section, we have an open profile cross section. And here on the right is a so-called general cross section that we build with the PBMSECT web app. So let me go ahead and go through the tutorial. Now, to start off with, I'm going to download a bulk data file, and I'm going to open the Beams viewer first. So here, we'll navigate to the Sol 200 web app. We will open up the Beams viewer. Now, the Beams viewer is a lightweight tool to look at your line elements in your bulk data file. So let me go ahead and import the bulk data file. And here on the screen, we get three beams, if you will. Here I could do things like turning on the beam labels. But here what's important is that this is our starting point. We want to replace these bulk data entries. So here we want to replace the P bar, the P beam. We want to replace these entries with arbitrary beam cross sections defined by the PBMSECT and the PBRSECT entries. So let's go ahead and get started with this procedure. Let me go ahead and maybe I'll leave the Beams viewer open for now. Let me jump back to the Size web app and open up the PBMSECT web app. I'm going to import the bulk data file that contains those three beams. And now I'm going to go ahead and create a new arbitrary beam cross section. So here, this first cross section, let me look at my notes, is going to be a PBRSECT entry. We're going to give it PID 8. We're going to use the existing mat1 entry that's defined in the bulk data file. This is going to be a closed profile. And now I'm ready to construct the arbitrary beam cross section. Here, let's go ahead and make sure that our grid is sized to 20 units of length. Now, these units are going to be the same units of length that you use in your bulk data file. So here, I'm using units of length of millimeters. So we need to define the width and height here. This is also in units of millimeters. So here, let's go ahead and create points on the grid that you see here on the right hand side. We'll create a point on the top left, the top right, the bottom, and this bottom left hand corner. We'll create these additional points, and in a moment you'll see why I'm creating these points that you see here in the middle. Let me go ahead and repeat the process for the other side, and let me create one point here in the middle. And now that I've created these points, let me go ahead and create some lines. So now it's time to connect the dots. So let's go ahead and just connect them. So I click the first point, and then I click the second point, and we'll just go ahead and repeat the process that you see here on the screen. Now, I'm going around the outside of the, the perimeter of the cross section. Here, if we look at the lines, so far there's no type designation for these lines. I need to specify which lines are part of the outer perimeter, and here I'll show you how to do that. Click on Select Lines of Outer Perimeter here on the left-hand side of the screen. We are going to select every line that you find in the outside of the cross section. So here, all of those lines are now blue. If we look down here, we now have the respective entries to define at least this cross section. So if we turn on the preview, this is what the cross section looks like. As we build the cross section, I encourage you to run MSC Nastran. So here we'll click run MSC Nastran. MSC Nastran is being run in the background. Here in this next box, if you will, we get the F06 output. We can use this to confirm if we've had a successful run. Here on the left-hand side of the screen is what MSC Nastran's interpreted arbitrary beam cross-section looks like. So things look good here. We can continue building up our ABCS, or arbitrary beam cross-section. So let's go ahead and continue connecting the dots. So here we'll go ahead and select these points, and then we'll do the same for these other points. So notice what's happening here. If we turn on the preview, the blue lines are the outer perimeter lines. Every other line is going to be classified as a branch line. So here, lines 11, 12, and 13 are going to be defined as branch 1. Lines 14, 15, and 16 are the second branch, and that's known, or here you see it's labeled as BRP2. If we look here, we have two new set 1 entries. Set 1 802 is going to be BRP1, so that would be these lines. BRP2 is going to be set 1 803, so that's going to be these 4 points, which is these green lines that you see here on the screen. So we'll go ahead and repeat the process to create our last few lines. So let me go ahead and turn off the preview. Select these 3 points. Now, whenever you're making a line, whenever you're making a wall that I've shown you here, where you're going from one side of the cross-section to the other cross-section, I encourage you to use a minimum of 2 lines. So here we're using lines 17 and 18. Try not to do this. So let me remove these 2 lines, and let me go ahead and create this line, and then select these 2 points. So now here, I've just defined 1 line. So here, I do not recommend using this configuration when you're defining your arbitrary beam cross sections. I always recommend using 2 lines to define a wall like this. So let me go ahead and remove that line and finish the construction of this arbitrary beam cross section. So let's go ahead and turn on the preview. Remember, we want to make sure that we have outer perimeter lines defined here. So here we see that they're defined as blue. Let's go ahead and make sure that we have the bulk data entries here. We have the respective point entries, where the point entries correspond to each point here on the screen. And then the set 1s are used to define the various lines that you see here on the screen. So let's go ahead and run MSC Nastran. And what I want to make sure of is that the MSC Nastran cross-section looks very similar to our constructed cross-section on the right. So here on the left is what MSC Nastran thinks the cross-section looks like, and here on the right is what cross-section we want it to be. I always recommend to perform this comparison just to make sure MSC Nastran is building the cross-section properly. Let's go ahead and review a few more things. Everything looks good here, so I think we can move on to the next cross-section. In this next cross-section, we are going to build an open profile cross-section. So let's go ahead and repeat the process like before. We'll click on Create New Entry. So now we have the opportunity to configure a new cross-section. I want to use the PBMSECT entry this time. I want to maybe use the existing MAT1 entry. This is where I select whether or not I use a open profile, a closed profile cross-section. And now we're ready to build our cross-section. Now, this is pretty much going to be a near repeat of the previous cross-section. We're going to go ahead and build a few points in the corners. We're going to build these points for the loops or the branch lines, and then here we're going to build some points for the interior wall of the cross section, if you will. And then this point in a moment, you'll see what that point is used for. So let's go ahead and navigate here in the top bar to the line section and click create lines. So like before, I'm going to connect the dots. So here point A and then point B, point A and then point B, and so on and so on. And then here, I'm not going to connect these final 2 points. Remember, this is an open profile section that we've defined here in the form field. Now, remember, always click select lines of outer perimeter and make sure that you have defined these blue outer perimeter lines. So now, just to make sure things look good, let's run MSC Nastran and let's look at the final cross section. So things look good. So far, so good. Let me show you what happens if you select close profile. So now form is equal to CP. If I go to the bulk data entry, if you look at the form field, it now says CP. Let me run MSC Nastran and let me show you what the difference is. Here, MSC Nastran will automatically generate a line between this last and beginning point, but this is not what we want. So let's go ahead and go back to open profile. Let's run MSC Nastran and let's make sure that we have an open profile. So things look good so far. Let me go ahead and finish creating these additional lines. Let's go ahead and create a line here and a line here. And then remember, when you're creating a line from an outer perimeter to another outer perimeter line, I always recommend using a minimum of 2 lines. Trying not to use 1 line. So let's go ahead and look at the preview. Things look good here so far. Let me go ahead and run MSC Nastran. So this here on the left is what MSC Nastran has interpreted the cross section to be. Now, I want to leave you off with a few additional comments regarding this cross section. Maybe you want to modify one of the thicknesses of the walls. So here, let's look at line 13, and let me go ahead and adjust the thickness of that line. Maybe I want to beef up that particular line. So you can do that as I just showed you. Find line 13 for the thickness column, specify the value you want. And let me go ahead and run MSC Nastran again. And then here we see the update. So line 13 is now, or rather line 13 has a larger thickness than, than before. A few additional comments. So here we get these labels. These labels for the actual cross-section generated by MSC Nastran mean the following. This line that you see here on the top left is the distance between the top outer fiber to the shear center. This next line is the distance between the shear center and the outer bottom fiber. And here are the same. This line here is the distance between the outer left fiber to the shear center. And this next line is the distance from the shear center to the outer right fiber. Here, when you look at the preview cross-section, we get some height and width distance markers. This height value is the distance between the topmost point and the bottommost point. This height is not the distance between the outer fibers, between the outer top and the outer bottom fibers. It is the distance between the point to point distance. The same is said for the width. So here we go from this left-handmost point to this right-handmost point that you see here on the screen. These width and height are not from thickness to thickness. It's from point to point. But these shear center distance lines, these are from the outer fibers to the shear center. So that is the second cross section. Let me go ahead and move on to the third cross section. So like before, let's go ahead and navigate here and create a new entry. maybe in this case, I think we're going to use the PBMSECT entry. Let's go ahead and use the same mat1. Here, we're going to use a different method of constructing the cross-section. So I'm going to use form equals GS. And now let me go ahead and make sure everything looks good. Okay, perfect. Let's go ahead and start creating this cross-section. I'm going to build 4 points on the corners. And now I'm going to click create lines, and I'm going to create these 4 points. And now let's go ahead and jump, or before I do that, always remember to click select lines and define your outer perimeter lines. Let me go ahead and click on run MSC Nastran here in the top right hand side. Alternatively, you can just scroll to the section. And let me click on preview. So this is what the cross-section looks like. It's just one continuous cross-section. Let me click Run MSC Nastran. We want to confirm MSC Nastran interprets this cross-section properly. And here on the left, this is what MSC Nastran has interpreted the ABCS to look like. So far, so good. Now, I want to create some internal holes, if you will, in the cross-section. So how do we do that? Let me go back to Create Points, and let me do that by clicking a few points in the interior, and maybe I'll do this. Now I'm experimenting. I've never created a cross section like this, so we'll go ahead and see what we get like in a moment rather. So let me go ahead and connect the dots rather. So you can see I'm trying to build these internal holes, if you will, and we'll finish in a moment. Let me go ahead and go to Run MSC Nastran, and we'll go ahead and run this and see what we get. Okay, perfect. So here on the right is the cross-section that we want to build. Here on the left is what MSC Nastran has interpreted the cross-section to look like. This is, again, very important. I always recommend to perform this check. Now, what more is there to say about this cross-section? Let me look here. I'm just looking at my notes if there's anything else worth saying here. Oh, right. So let's look at the F06 output. Here, if we look at the F06 output, we get a equivalent P-beam entry. Yes, we've defined a PBMSECT entry, but Nastran ultimately will generate its own internal PBM entry that's equivalent to this. And this entry that's outputted to the F06 file is useful in the following way. Let me go ahead and show you why that is. What you can do with this information, let me show you a closer view. This outputted PBM entry defines things like the area of the cross-section, the values for the inertias of the cross-section. That's all available here in this equivalent PBM entry. If you repeat this for the other two cross-sections, you get the same thing. You get an equivalent PBM entry, and you could use this to look at how much, what's the area of the cross-section, what's the inertia, and things like that. So that's the last thing I wanted to show you here in the PBMSECT entry. Let's go ahead and now download our updated bulk data entry. So let's go ahead and do that. And let's open this zip file. And let me show you these files side by side. So here on the left, this is going to be these 3 beams that are using PBAR 5, 6, 7. Now, what I want to do here, let me go ahead and comment in this new updated file. And the reason it's been updated is because now it includes all the PBRSECT, the point, the set one, and the PBMSECT entries for those 3 cross sections. So this is our new updated bulk data file. Let's go ahead and remove the old PBAR and the old PBeam. So we're going to add these common symbols, the dollar signs, Nastran will ignore these lines when it reads the file. Let's go ahead and renumber these 3 beams. So the first beam will now be PBRSECT 5. These next PBMSECT will be PBMSECT 6, and then the last PBMSECT will be PBMSECT 7. So let's go ahead and make sure we have the right spacing, and now we'll go ahead and save this file. And let's go ahead and open a new window for the beams viewer. And let's go ahead and import this updated bulk data file. So we'll go ahead and upload this updated bulk data file. And now if things went well, we should be seeing our updated cross sections or our updated beams here that you see on the screen. So in this other window, this is what the 3 beams look like before. We were just using these P bars and these PBM entries to define the beams. But now we're using the PBMSECT and the PBRSECT entries to define our arbitrary beam cross sections for these 3 beams. So I think that is basically the end of the tutorial. Let me show you again that this tutorial is the second tutorial available in the Sol 200 web app under the beams tutorials. So with that, I'll stop there. Thank you so much for watching.